The subject of this evening's lecture is the medieval agricultural revolution, traditionally referred to as the medieval agricultural revolution, and traditionally dated to the period between about the 10th and the 13th centuries. It involved a major expansion of arable farming and saw the serialization of large swathes of England and indeed of Europe. So although I'm talking about England tonight, much of what I say could be applied to many parts of Europe. It fed an exceptionally rapidly growing population, but also fueled wealth disparities. This is the period that saw the emergence of England's first landowners, its first local lords. So I'll begin by introducing some of the key elements of the revolution and some of the debates around it. For example, whether it should be called a revolution. Then I'll present some new archaeological evidence from a project called Feedsax, Feeding Anglo-Saxon England, Feedsax for short. A project that I think is transforming our understanding of the conditions in which early medieval crops were grown in England and the timing of key agricultural innovations. So, for example, were those innovations already in place by 1066? Or were they associated with the Norman conquest, with the Norman yoke? Finally, I'll conclude with some reflections on what brought this period of growing agricultural outputs, population expansion, and relative prosperity to an end. So let's start with the serialization of the English countryside. So as I just mentioned, the period we're talking about saw this exceptionally rapid population growth. And I'm going to show you some figures here, all of which are really very rough approximations, but they give you an idea of the speed with which the population was growing in this period. So we think that the population of late Roman Britain, and we're talking about the 3rd, 4th century, was somewhere on the order of 2.5 to 3 million. In the post-Roman centuries, the 5th, 6th, 7th centuries, we're quite confident that the population collapsed really quite dramatically, although how dramatically is anyone's guess, perhaps by as much as 1 million, maybe even more. By the time of the Domesday Book, the population had more or less recovered to Roman levels, to late Roman levels. And by 1300, it had more or less doubled. And you can also see here some estimates for the number of acres that were under the plough in these periods. So you can see, I think, really very striking population growth. So how did medieval farmers manage to feed such a rapidly growing population? In many parts of the country, but not all, this was achieved by various forms of open field farming, especially the type known as 2 or 3 field farming. This is where most or all of a community's arable lay in 2 or more large, unenclosed fields. The holdings of individual farmers took the form of scattered strips within those fields, intermingled with those of their neighbours. So what you see on this slide are the fossilized ridge and furrow earthworks of such a field system, formed by the mouldboard plough, which I'll say more about later, with a village, a medieval village, at its heart. Now, medieval farming involved several technological innovations, including systematic crop rotation and the mouldboard plough. I'm going to talk about those in a moment. But according to the grand narrative of the agricultural revolution, these innovations led to a sort of great leap forward in terms of productivity, ultimately shifting prosperity from southern to northern Europe. Now, this narrative has rightly been criticized for many decades as technological determinism, and there are undoubtedly problems with the very notion of an agricultural revolution in this period. But there is no question, I think, that the spread of open field farming really was one of the transformative changes of the Middle Ages. Now, we're going to look at some new evidence that should definitely make us think again about this narrative. But first, I briefly want to mention this book, which was published in 2017, Against the Grain, because the author, who is not a historian, he's not an archaeologist, he's a political scientist, the author makes a direct link between cereal farming and wealth inequalities. So Scott's focus is on the prehistoric origins of farming. He talks mostly about the Neolithic. But his general thesis is that in the past, as cereal farming increased, so too did wealth disparities. That, by the way, isn't really a new idea, but he has expressed it maybe most recently, and he expresses it in a very sort of engaging way, so it's worth a read. Now, medieval Europe is an obvious example of what he's talking about, although in fact he doesn't mention it. The new forms of cereal farming in the Middle Ages that we're going to be talking about generated substantial, regular surpluses, and that is key. It allowed many more mouths to be fed, of course, but it also allowed landowners to amass and mobilize these surpluses, ultimately by exploiting the labor of others, by exploiting the labor of those who actually worked the land. So in England, from the 10th century onwards, kings granted units of land to local lords. And by the time of the Norman conquest in 1066, there were thousands of such landowners, and each with their own estates, prospering from rents extracted from peasants who worked the land. It is the expansion of cereal farming that made this possible. And that brings us back to Scott. And here's a little quotation. The key to the nexus between grains and states lies in the fact that only cereal grains can serve as a basis for taxation. What does he mean by that? I think what he's saying is that cereals, and uniquely cereals, possess certain qualities that make them an ideal medium for tax collectors. I should say cereals uniquely amongst crops. They make them an ideal medium for tax collectors. So they ripen and they are harvested at predictable points of the year. They're easily stored, easily transported, easily measured. This means that landowners could enrich themselves more readily from land sown with cereals than anything else. Not only are cereals easily taxed, but a land unit sown with cereals will, of course, feed many more mouths than the same land unit used to graze livestock. That's something we're all very aware of at the moment. Hence the exceptionally steep population growth that we saw earlier. The question of how early medieval farmers were able to grow enough cereals to supply this rapidly expanding population, as well as the expanding markets of this period, has generated a lot of debate for a long time. So when were innovations like the mouldboard plough actually first introduced? Was there really a technologically driven transformative moment, or was there instead a sort of gradual process of serialization? Was change driven by top-down pressure from greedy lords demanding ever larger surpluses, or is it evidence of bottom-up peasant agency? And on and on. There are many unresolved questions that have been argued over for decades. But I think it's fair to say that the debate has, to a large extent, reached a kind of impasse, with no consensus being reached. So why can't we agree? I think it's largely because, as I say here, we lack direct, closely dated evidence for medieval fields themselves, and we don't really know anything about the conditions in which crops were grown in this period. And, well, related to this is the fact that researchers have to rely on a relatively small number of indirect sources like maps and charters, documents recording land transactions that really don't tell you about farming as such. And many of them were produced a great deal centuries after the period we're talking about. They're really quite late. They're certainly written long after the main period of change. And I'll show you here a tiny image. I'm sorry it's so tiny, but an image of a very important map, the Laxton map, which is a wonderful depiction of a fully developed open field system, but it dates to 1635. It's really late for what we are talking about. So what is needed really to break this impasse is new, preferably direct evidence. And that, thanks to the project Feeding Anglo-Saxon England, we now have such evidence. And that is what we're going to look at next. So the project, which is sort of finished, but still bits of it are still going on. It was based at the University of Oxford with a collaboration with Leicester, and it involved the work of really quite a large team of experts, quite a diverse team of experts, and here they are. So it's really just to make the point that this is the result of the work of an awful lot of different people, what you're about to see. Now, the aim of FeedSACs was to generate direct evidence for medieval farming by analysing plant and animal remains from archaeological excavations. Our primary source material was not documents, was not written evidence, but rather bioarchaeological evidence, so things like preserved plant remains, preserved animal bones, and so on. So on the left there, rather unprepossessing little pile of burnt bits, are actually medieval grains and associated weed seeds that have been preserved by accidental charring. So it probably happened when they were trying to dry the grains, or maybe a granary burned down, but these charred plant remains are a really important source of information. And then we have animal bones, and these are in fact the bones from cattle feet, which, as you'll see, will become important later on to my story. And then on the right, we have a pollen core. So we did look at pollen evidence, pollen grains, to understand questions about wider land use, but I'm not going to talk about that today just because we don't really have the time. So where does our source material come from? Well, it comes from hundreds and hundreds of excavations from across the country. I'm afraid you will have noticed that an awful lot of them come from southern and eastern England, areas that were very much dominated by open field farming. I'm afraid that's not at all what we wanted. It's not for lack of trying to find material from the north and west, but there is simply less well-preserved bioarchaeological material from the north and west. It's harder to identify sites, and so we've ended up with a reasonable spread, but it's not perfectly representative. I'm just going to quickly mention the main methods we use. I'm not going to go into any technical detail, don't worry about that. But we really looked, first of all, at weeds, at functional weed ecology. This is a way of studying the weeds that grew in amongst the crops. Because as you're about to hear, these tell us about the soil conditions in which those weeds grew, and therefore the soil conditions in which the associated crops grew. Different sorts of weeds grow in different conditions. Then zooarchaeology is simply the study of animal bones from archaeological excavations. Archaeobotany, ditto, but looking at plant remains. And finally, we undertook something called crop stable isotope analysis of medieval grains. And that is just another way, by looking at the kind of chemistry of those grains, it's another way of establishing the soil conditions in which those crops grew. So it's quite novel. We were quite novel in our approach, I think. So now, finally, we're going to look at some results. And I'm going to present these according to a kind of framing device that I've called the mouldboard plough package, that consists of 3 key elements of medieval farming. The first is extensification. I'll explain that in a moment. The second is crop rotation. And the third is the use of the mouldboard plough. So let's start with this, the extensification of cereal farming. First, I think I'd better explain what I mean by extensification. So here is a little diagram that my colleague Amy Bogard has produced. I think is a useful way of explaining this. If you're a farmer and you want to increase your overall crop yield, at least if you're a pre-modern farmer, you can do one of 2 things. You can cultivate your land more intensively by investing more input per land unit. And by input, we're talking here about manure and human labor. Now, you can do that, but that tends to limit the amount of land that you can cultivate. So intensive farming tends to be smaller in scale. Alternatively, you could extensify. That is, you could cultivate more land while investing less input per land unit. So you can see you have labor-intensive methods, which tend to be small scale, or you have land-extensive methods, which are larger in scale. As cereal farming expanded in scale, we would therefore expect to see a trend towards lower input and therefore lower fertility systems. So the lower fertility is a really important point, lower fertility soil conditions. Open field farming, medieval open field farming, is an example of a super extensive, low input type of farming. And that's because fertility wasn't maintained by really intensive manuring, but rather by short, regular fallow periods when the land rested and was grazed by sheep whose droppings topped up the soil fertility. So it's a low input, low fertility system. So how can you tell how intensively or extensively cereals were farmed? Well, the key here is the weeds. I'm going to be talking about weeds quite a lot tonight. Many of you are gardeners, but you'll be familiar with some of them. So arable weeds are the key. The weed seeds that we analyze come from weeds like cornflower that grew in amongst the medieval cereal crops and were harvested together with them. Why are they useful? Well, again, as you gardeners and allotment holders will know, some weeds, like nettles, these are nettles, thrive in high fertility conditions, while others will not do well in those conditions. They prefer poorer soils. Because arable weeds reflect the soil conditions in which they grew, so different conditions produce different types of weeds, they also provide us with direct evidence for the soil conditions in which crops grew. That's simply, that's the underlying principle. It's quite simple. Now, in order to interpret the medieval weed seeds accurately, what sort of soil conditions do they represent? We need some modern baseline data. This is about as technical as it's going to get, so bear with me briefly, this one slide. This represents the work of my colleague Amy Bogard in comparing the weeds from tiny, intensively manured cereal fields in northwest Spain, in Asturias, and you see that in the top right of this slide, to very low input, low fertility fields in Haute-Provence in the south of France, which you see in the top left. So in the top right, these tiny fields are used to grow some sort of special, I think it might be a type of wheat that is used to bake a special cake or bread that they only eat once a year. So they're really tiny, they're almost like kitchen gardens, but they're using them to grow cereals. In Haute-Provence, where you can see they look like, regular sort of wheat fields, very extensive. So she conducted a botanical survey of the arable weeds from both systems and found that the results produced, so she then produced a sort of discriminant function analysis that you can see at the top of the slide, and she found that the weed floras found in the two systems, the very intensive and the very extensive, formed two quite distinct groups. So it is possible readily to distinguish between the types of weeds that grew in small, intensively cultivated fields and those that grew in large, extensively cultivated fields. So that was kind of a test. And if you want to try this yourself, and I'm not a botanist, so I'm only going to present this very simply, low-growing, slow-growing weeds, like the one you see there on the left, with almost needle-like leaves, tend to be associated with very poor, low-input soils, whereas the sorts of weeds that would grow in most people's gardens in this country, which are moderately fertile, grow like nettles, relatively fast, relatively tall, with broad leaves. And these are the functional traits. I'm not sure if you can see them, but she looks at things like canopy height, flowering duration, the area of the leaves. All these things tell you whether that weed likes low fertility or high fertility conditions. So I've spent a little bit of time reviewing that so that you kind of can understand the results, which I'm now going to show you when we apply this model to medieval weed seeds. So here are the results. They're just for the central zone because it was the central zone, the breadbasket of England, that really produced the most samples, so produced really the best results, basically. Each of the dots that you see represents one archaeobotanical sample, one sample of weed seeds. And you can see the date runs along the horizontal axis at the bottom of the slide. And along the vertical axis, you see scores from 6 down to -10. So scores that are below zero, so dots that are plotting below zero represent low fertility conditions. Those plotting above zero equal higher fertility conditions. And essentially what the graph shows clearly is diminishing scores and so decreasing fertility over time. That's what this dotted line is showing you. It's going down. Soil conditions are becoming less fertile over time. Now, there is a hint, I think, of a bit of a step change around about the 8th century. So in these earliest phases, you can see the samples are plotting relatively high. Now, we don't have many samples, but they have relatively high scores. But after about 700, pretty much everything is below zero. It all counts as extensive low fertility farming. Now, what's interesting is that we know from written sources of the 12th and 13th centuries mostly that farmers were working really hard to maintain soil fertility through manuring, through hand weeding, through planting legumes and other green manures. And I've had historians argue with me and say, but they were working so hard to maintain fertility. Well, they undoubtedly were, but the weeds tell us that whatever farmers were doing, it just wasn't enough to reverse that downward trend. That is just an ecological fact. That is what the weeds tell us. So that's interesting. So that's extensification. That's all I want to say about that for now. Let's move on to talk about crop rotation. Now, collective decision-making about crop rotation and fallow grazing was a fundamental feature of the 2- and 3-field systems. Rotation, of course, allowed a higher proportion of a village's arable to be undercrop at any one time. Now, farmers had to agree in a system like this when and in which field to sow different cereals and which field to leave fallow. I mean, obviously, you can't have your sheep grazing in a fallow field immediately next to a crop field. You have to keep them separate. So you have to agree what you're going to do. Farmers had to cooperate and had to agree. And they might, in a typical system, have autumn-sown wheat in one field, spring-sown barley in another, and then the third field left fallow. That's the kind of classical model. And then the next year you rotate and you have barley in what was the wheat field and so on. So what we did was to look at the crop stable isotope values in cereal grains. Specifically, it was the nitrogen values that we were interested in, to see whether different cereals had grown in the same soil conditions and therefore potentially in rotation. So if barley and wheat, for example, are grown in rotation in the same sets of fields, they'll have isotope values that are basically the same. If they're different, if those values are different, they couldn't possibly have been grown in rotation. So what did we find? We found when we normalized our results across all of our sites, well, we found this. So in the earliest phase, which takes us right back to the 7th to 9th centuries, you can see the values are really widespread. They're all over the place. There's very little evidence here of rotation. The different colored dots, by the way, are different types of cereals: oats, rye, wheat, and barley. So the earliest phase, very widespread. You can see in the next phase, which takes us to the late 9th century up to the first quarter of the 11th century, a little bit, that variability is a little bit reduced. And then in the last phase, which is the 11th to 13th centuries, it really reduces a lot. So we think that it is in that period, the 11th to 13th centuries, that crop rotation, systematic crop rotation, is really being quite widely practiced. But this is the first sort of direct scientific evidence we've ever had for that. We've had to rely entirely, really, on written sources until now. So that's crop rotation. And we can now look at this question about the mouldboard plough. When did it come into widespread use? This really kind of disruptive technology of the Middle Ages. So what was the mouldboard plough? What made it so important? Well, the main tillage implement of the Roman period in the West was the scratch plough, or ard, which you see at the top here. The ard or scratch plough, as the name suggests, really just scratches a furrow into the surface of the soil. What the mouldboard allows you to do is actually turn the soil over, as I hope you can see in this diagram. This is a nice early medieval image of a mouldboard plough. So you have a coulter that cuts vertically down into the soil, and then a mouldboard that turns it over. And that ability to, that complexity in the mouldboard plough allowed farmers to expand more readily onto heavier, more fertile, more productive soils. And that's a really key feature of this medieval arable expansion that we're talking about. Now, we know that the mouldboard plough was around in England quite early, already in the 7th century. And the reason we know that is that archaeologists have excavated a piece of a mouldboard plough in Kent, associated with a royal monastery at a place called Lyminge. So we know it existed. They knew of the mouldboard plough. So the real question is, when did it change from being a rarefied, high-status piece of kit that you might use in a royal monastery to being something that most farmers had access to? And we know that by the time of Domesday Book, an awful lot of farmers were using the mouldboard plough. So when did that happen? When was that tipping point? Or indeed, was there a tipping point? Was it just a gradual increase over time? So again, weeds are key. Again, you may know that some weeds absolutely thrive in highly disturbed soil conditions, like those produced by mouldboard plough. So, for example, thistles, which you see on this slide, or ground elder, if we're talking about my garden is absolutely infested with ground elder. Thistles and other weeds like that positively love being chopped up into little pieces because they regenerate very readily from tiny bits of root. If you leave even a tiny bit behind, a new plant will grow. Medieval writers like Walter of Henley knew all about this, and thistles are much complained about in medieval texts. So as he says here, if thistles are ploughed up before midsummer, for each one shall come up 2 or 3. So he said, thistles are difficult to kill off, even with a mouldboard plough. In fact, they really like the mouldboard plough. So ards and ard and plough cultivation produce different types of weeds, because there are lots of weeds that don't like this at all. There are weeds that require low disturbance to survive. So they would cope with ard cultivation. Others, like thistles, prefer high disturbance conditions. So again, we needed some modern baseline data with which to compare our medieval samples, and this came from 2 sources. The first is Highgrove Home Farm, yes, home of Duchy Originals, you biscuit lovers out there. As you may know, they grow heritage cereal varieties, and they grow them organically. They practice crop rotation. And our second source was a village called Laxton in Nottinghamshire, which refers to itself as England's last open field village, and indeed there is a still functioning open field system there. And here you see the FeedSACS team conducting a botanical survey at Laxton. So we went out and actually looked, well, what kinds of weeds grow in these systems? And again, Amy Bogard produced a kind of discriminant function analysis. Don't worry about this slide too much. The point is that it was quite easy to separate out the sorts of weeds that grew in the really low disturbance conditions in the hay meadows at Laxton from those on the right here that grew actually in the arable fields that underwent the sort of disturbance of modern ploughs. Of course, they used modern ploughs at both Laxton and Highgrove. But so it was possible to separate out high disturbance and low disturbance weeds quite readily. We refined the picture using some really remarkable data, because we thought it was important to look at some fields that are actually being ploughed with a mouldboard plough. And we found such a place in Germany at an experimental farm at the World Heritage Site of Lorsch Abbey, which is near Frankfurt, or south of Frankfurt. So this is a working farm where they carry out cultivation experiments using really high quality archaeological replicas, like the mouldboard plough in this image. And they very kindly supplied us with weed data so that we were able to introduce this into our model. So we applied that model then to our archaeological samples. And here again we see the weed samples for the central zone, but this time in relation to soil disturbance. Before it was fertility, now we're looking at soil disturbance. So the arrow on the right, that blue arrow, I hope you can see it. I probably should have made it a different color. But the arrow indicates our, what you might call our mouldboard plough line. In other words, samples plotting below that line grew in low disturbance conditions, consistent with the use of an ard. The samples above the line grew in high disturbance conditions, consistent with use of a mouldboard plough. And here you can see, whereas soil fertility was going down through time, you can see, I hope, that disturbance is going up through time. It is increasing through time. Although we do see, and you can see this quite readily, some continuation of low disturbance cultivation, which suggests, as we would expect, that some farmers were still using an ard, and we know that the ard continued to be used throughout the Middle Ages. But the mouldboard plough is clearly becoming more and more prominent through time. So we'll leave plant remains behind and look at the animal bone evidence, the evidence from cattle bones specifically, and what they tell us about the spread of the heavy mouldboard plough. Now, the first thing we did was to identify a trend towards more male animals and towards older animals. And this trend, I think you can see, peaked in the 10th and 11th centuries. So we're looking really here at the darker part of the bar. That is the proportion of animals that were used for what's called secondary products, that is dairy and traction, but probably in this early period, mostly traction. And you can see there's more and more and more until it peaks in that period, 850 to 1066. You might wonder why it seems to reduce again after that, and we think that is because people are increasingly using horses for traction once you get to that later period. But they're definitely increasing. Cattle are increasingly being used for traction up until 1066. We then also looked at these foot bones that I mentioned early on. And the reason for that is that the strain of pulling a heavy anything, but a heavy mouldboard plough would cause pathological changes to the feet of cattle. I mean, basically, they develop a kind of arthritis over time. And these pathologies allowed us to define what we called a draft cattle signature for some sites. And the sites that you see on these maps with a draft cattle signature, I hope you can see this, are marked with a little ox. So those are the ones with this signature. So the maps show how the proportion of settlements, excavated settlements with this draft cattle signature increases over time. So here on the left, you have the period 400, 700, and then 600 to 900, and it's really quite a low proportion of sites have this signature. But when we move to later centuries, 800 to 1100, the proportion goes right up, and for 1000 to 1200, all the sites we looked at produced a really pronounced, a really clear draft cattle signature. So something is clearly going on. So having looked at the evidence for extensification, for crop rotation, and for the use of the mouldboard plough, we can now compare the timing of their appearance and spread to changes in rural settlement. And we say rural settlement, but really we're talking here about farms and villages, actual farms and villages of this first part of the Middle Ages. So that's what I want to do next. Now, rural settlements in early medieval England, and when I say early medieval, really, I'm going actually right up to 1200 in the discussion today, but but anyway, rural settlement underwent, I would say, 3 distinct episodes of change in those centuries. And these, I think, can best be understood when viewed against the backdrop of the changes in farming that we've just looked at. So the first of these episodes is what historians have come to call the long 8th century. So in fact, the period from more or less 680 to more or less 830. What makes that period different? What sort of changes do we see? What innovations? And we see quite a lot of changes in this period. Mostly in central and eastern England, but the changes are clear. So we start to see settlements become associated with the first post-Roman droveways, the first livestock enclosures, the first hay meadows, and so on. Prior to this, we don't have evidence for any of that. They had it in the Roman period, and then it all disappears in the 5th, 6th, 7th centuries, and then in the late 7th century, you start to get these features again. Why is that interesting, or why is it important? Because I think there are 2 really significant, I think, implications for the appearance again of things like livestock enclosures and droveways and so on, because it tells us that livestock were being managed in new ways that required their movement to be controlled, so that they didn't just stray off into fields or stray off into farmsteads and start nibbling on the thatch or whatever. So somehow they must be being kept close to the settlements, and so you have to really manage their movements and make sure they don't get into trouble. So that's the first implication. And the second one, which is equally important, I think, is that farmers must have been cooperating. They must have been pooling their labor in order to construct these droveways and these very extensive complexes of paddocks, corrals, whatever they are, these livestock enclosures, because they are quite extensive. They involve quite deep ditches and banks. They would have involved a lot of work, much more than could be done by just one household or even 2 households. So these were large-scale undertakings, and I think those 2 implications are quite significant. So we see the droveways, the enclosures, the hay meadows, but we also see investment in this period in the first centralized crop processing and storage facilities since the Roman period. The first medieval grain drying ovens and malting ovens, like this wonderful malting oven from Northamptonshire, from Higham Ferrers, they appear for the first time. The first medieval water mills also date to this period. Here's a really early one from Kent. We even have a few barns known from this period. I don't want to exaggerate. I don't want to say that they're appearing absolutely everywhere, but it is a clear phenomenon, and they are popping up increasingly as there is more excavation. So these features, like the malting ovens, the water mills, barns, and so on, I think could be seen as sort of capital projects associated invariably with high-status settlements, royal sites, royal monasteries. And they are, of course, tangible signs of the wealth generated by cereal surpluses, the very cereal surpluses that they were designed to store and process. This is also when the first large archaeological deposits of charred grains appear, probably reflecting larger harvests that are being processed and stored in new ways, and so they're occasionally catching on fire and being dumped. And I think all of this, when you put it together, reflects a shift from relatively small-scale, intensive farming that is not leaving much of an archaeological footprint to larger-scale, low-input regimes and a new emphasis on surplus production. So that's the long 8th century. The second key change happens in the 10th century. You might even be able to argue it's the middle of the 10th century, with the appearance of the first distinctively aristocratic settlements. Sometimes people call them proto-manors. These, by the way, these are just reconstructions. On the left, you see a site called Cheddar. On the right, you see another one called Fackham Netherton in Hampshire. These were the residences of local lords who had been granted land and who mobilized the cereal surpluses it generated to fund elite lifestyles of considerable comfort. The evidence indicates that systematic crop rotation and use of the mouldboard plough, as we saw, first became widespread in the 10th and 11th centuries. A study of preserved cereal grains from the same period indicates the development of regional trends in crop specialization. For example, bread wheat in the Upper Thames Valley, or oat in the southwest, and also actually in Staffordshire as it happens. So the timing of those developments does suggest that, if you like, top-down decisions by local landowners did play a role in promoting the spread of the mouldboard plough and of systematic crop rotation. Even if the earlier developments, the extensification, really came too early to have anything to do with lordship, local lordship. The third and final change took place during the 12th and 13th centuries. This is when nucleated villages, so-called nucleated villages, began to appear in parts of the country, again, mostly in that central zone. And these villages have these very distinctive planned arrangements of contiguous, clearly defined house plots. So these villages, I think we can now be quite sure, were associated with the Norman conquest. We don't have any pre-conquest examples. And John Blair has described their impact on the landscape as, I quote, weightier and more permanent than any since the Roman occupation. And indeed, of course, we can still walk through villages like this today. Even so, as dramatic as this change is, there is nothing in the archaeological record to suggest that there were any major innovations in farming systems in this period. The main innovations had already happened. Crop rotation was widespread. Use of the mouldboard plough was widespread. Extensification had happened centuries earlier. There are some changes, of course. The density of charred grains per sample does increase sharply, and you might think that's a slightly niche observation to make, but it does imply a scaling up of production. And similarly, analysis of sheep and cattle bones has suggested to some researchers an increased number of livestock overall. Written sources and scatters of pottery sherds associated with manuring also indicate that in this period, the 12th and 13th centuries, farmers, landowners were going to considerable lengths to boost soil fertility by manuring, by planting legumes, by hand weeding, this sort of thing. Now, whether this was driven primarily by a desire to maximize outputs or by concern over declining soil fertility is impossible to know. Nobody explains why they're doing it. Regardless, the weed ecology of those fields demonstrates that these efforts failed to halt an overall trend, albeit a fairly subtle one, as we saw, towards diminishing levels of fertility. The weeds also reflect higher levels of soil disturbance, which we think reflects a more systematic use of the mouldboard plough within 2 and 3 field systems. In some places they were even ploughing the fallow 2, 3, 4 times in a cycle. So they're really churning up the soil. Indeed, the levels of disturbance from a weed's point of view is comparable to modern arable fields. There's really no distinction. I thought that was remarkable. They were able to achieve really high levels of disturbance and tillage using a mouldboard plough. So the 12th and 13th centuries saw a really broad continuity of agricultural regimes against a backdrop of an increase in the overall scale of arable farming. So I'm going to bring things gradually to an end. So, first of all, we cannot see from the evidence that Feedstacks has produced any single moment of revolutionary change. I don't suppose we were necessarily expecting to, but I mean, we might have come out saying, oh, it's the 10th century, it's the 11th century. Instead, what we see could be described slightly tongue-in-cheek as a long agricultural revolution. It began in the 8th century with several innovations. The shift to low input, large scale cereal or larger scale cereal farming is arguably the most significant, but it began too early to have been the initiative of local lords, local landowners. So where did this impulse towards extensification originate? Of course, we don't know for sure. We can't know for sure. It may have originated in royal monasteries like Lyminge or other royal centres. It may have been driven in part by population growth and indeed the emergence of the first formal markets since the Roman period. I haven't mentioned those, but they are there, and the first coin use, widespread coin use since the Roman period, dates to this period. In the 10th and 11th centuries, the spread of systematic crop rotation and the mouldboard plough is, I think, consistent with a degree of top-down pressure from local landowners to increase outputs. And then the 12th and 13th centuries, as we've just seen, saw a sort of scaling up of production, further regional fine-tuning of cropping regimes, and a new emphasis on bread wheat, the highest value cereal crop. You can get the most for that at market. But we didn't see evidence of any major innovations dating to this period. And throughout the whole period, soil fertility continued to decline. So was there a medieval agricultural revolution? Well, the evidence from feed sacks suggests that the different elements of the mouldboard plough package, so crop rotation, extensification, use of the mouldboard plough, did not come together in a sort of single great leap forward impelled by new technologies. Instead, what we see is a series of innovations, some of which had really quite a long gestation. So if you think of the mouldboard plough, we know it was there in England in the 7th century, but it didn't really see widespread adoption for about 300 years. So it doesn't become a widespread practice for several centuries. Crop rotation, probably the same. Nevertheless, the cumulative impact of these changes over 200, 300 years was transformative, or if you prefer, it was revolutionary. Now, where did these transformative changes in arable farming ultimately lead? Well, just over 700 years ago, Europe was emerging from a subsistence crisis of such magnitude that it is still referred to today as the Great Famine. Countless people perished, and it marked the end of the period of population growth and relative prosperity that we've just been talking about. The triggers of the Great Famine are clear enough. There's really no question about them. It began in 1315 with a whole series of extreme adverse weather events that caused a series of crop failures. On top of that, there was an outbreak of something called rinderpest, so it's a disease, a highly contagious disease that affects cattle and sheep, leading to a really catastrophic decline in livestock numbers. So all that is undoubted, but is it the whole story? After all, there had been adverse weather events and indeed famines and outbreaks of rinderpest before. Anglo-Saxon Chronicle's full of them. So what made this one so much worse? Was it exacerbated not only by growing wealth inequalities, many historians have made that point, wealth inequalities that of course were sustained by cereal farming, cereal surpluses, but also exacerbated by deterioration in soil fertility, the long-term net effect of low input, high disturbance farming regimes. Was this the end game of extensification? Experimental work is ongoing to try and answer these questions and to establish how a farming system that had fed a rapidly growing population for centuries, seemingly sustainably, suddenly crashed. Those are questions, of course, for another day. But I thought I would end by showing you this replica mouldboard plough being pulled by oxen at the experimental farm I mentioned earlier, this farm called Lauresham at Lorsch. Lauresham, they basically built a replica of an early medieval village, complete with fields and livestock. And they grow a range of crops using a variety of ploughs and a variety of ards, prehistoric, medieval, everything. And they record absolutely everything. They record weeds, they record yields, moisture levels, fertility, everything, you name it. It's a great site. You can visit it. It's open to the public. I highly recommend it. Maybe not on a very hot day, as I did, but still. It's remarkable, really, what they're doing there. And we're developing a collaboration with them that we hope is going to yield more data that can be used to address some of these questions we've been considering this evening. And I thought I would just leave you with a short clip of one of their fields being ploughed for the first time using a mouldboard plough. So they're really now trying to address the need for more data to really understand the functional weed ecology in fields that have been ploughed using a mouldboard plough, using an ard, ridge and furrow, no ridge and furrow, and so on. So I'll leave it there. Happy to take questions.
Thank you, Professor Hamerow. We do have time for some questions, so I'll start off with some from the online audience. The first one actually leads in quite well with your last point. What is the next stage of your research, and what kinds of other questions do you hope to maybe answer?
Well, we hope, I sort of touched on it at the end. I think this question of what happens when you extensify and extensify and extensify, and the soil fertility goes down and down, and the soil disturbance goes up and up. Can we model what actually would have happened after 200 or 300 years of that sort of farming? Of course, it does have relevance today because there is this trend, you may know, towards what they call no-till farming. And this idea now that this high disturbance type of farming that we've been doing, of course, for centuries, and mechanized now, but for centuries, is not ideal and actually does damage underlying soil fertility in a variety of ways. So it would be really interesting to see, well, what would that impact have been on the soil? So that's a big one.
So we've got a couple of questions that are sheep related. So I'll start off with the first one. Were you able to take account of the impact of the sheepfold system on the fertility of soil, or did the use of sheepfold to manure the arable land fall outside the period of your study?
Well, it almost falls outside the period of study. I mean, folding of sheep it certainly took place in the 12th and 13th centuries. They undoubtedly did it, and they're quite right to raise that. So it wasn't just spreading manure from byres and from middens onto fields, but of course sheep were folded onto the fields. That undoubtedly made the decline in soil fertility less than it would otherwise have been. But overall, the problem is perceptibly to raise fertility, soil fertility, requires a great deal of manure per land unit, a huge amount. And so sheepfolding will have helped, but clearly it wasn't enough completely to halt or reverse the trend.
So another sheep-related one before we open up to the floor. Is the lack of findings in the north and possibly Wales due to the topography, which was more suited to sheep farming, for example? Yeah. And did you look for sheep or other non-bovine remains?
We did, and we actually did a little study of sheep. I just didn't have time to talk about it. So the lack of remains in the north and west, we do have some animal bones, but on the whole, the more acidic soils in the north and west, the soil conditions in the north and west are less conducive to the preservation of animal bone. We didn't have great plant remains either from the north and west, to be honest. So, but it's also more difficult to identify early medieval settlements in those regions. So I think for all those reasons, we had less. But undoubtedly, there would have been hefting of sheep and this sort of thing in the north and west. the things that we looked at with the sheep bones was to see whether or not there was evidence. This is going to sound even more niche than what I was talking about before. Actually looked at the calculus on the teeth of the sheep to see whether or not they were spending more time grazing on stubble fields, because that's a very high carbohydrate diet, and it would result in increasing amounts of calculus on the teeth. So we did get some interesting results on that.
Thank you.
So we love sheep at Feedside. We love sheep.
After extensification, and how, did they reverse the declining soil fertility?
Well, we didn't check the weed. We only had a few weeds for the 14th century, and we didn't look later at all. So that would be another project and way to look at what does happen to soil fertility in the 14th, 15th, 16th centuries. There certainly is, as a result of the catastrophes of the 14th century, very dramatic implosion, decline in population, as you probably know, all over Europe. And as a result, of course, the demand for cereal farming, for cereals, decreased dramatically. The labor force decreased dramatically. And so, yes, I think we would have seen, I would guess, we would see a reversal of extensification, or at least a halting. But nobody's actually looked at the weed floors for those periods. So it would be a really interesting thing to do. It's an important question.
Thanks for a really interesting talk. I'm fascinated with people you said who said, oh, but they were doing all these things to keep up soil fertility. And I'm just fascinated by how, because your evidence seems so compelling, you can square that with the increase in population, but also the densification population implied by the creation of nuclear villages. So it's not just the population of England's going up, it's also getting dense enough that they're forming these little nucleus of course in the countryside. How do those two things, the decline in soil fertility and yet this rapidly increasing and densification of population, go together? Is there something else going on in the background? Because it's such a fascinating paradox.
So I think the increasing population would have made labour relatively cheap. So I think that absolutely is in keeping with the written sources that record, peasants out there spreading manure, hand weeding, doing up marling, all sorts of really quite, on the face of it, quite labour-intensive activities. But the problem is, I think these fields had become so extensive, so large, they were covered so much of the landscape that there just wasn't enough, in particular manure, to maintain fertility, given how, given the rotations and so on, the methods being used. So, as I said, whatever they were doing, it wasn't enough to reverse the decline in soil fertility. The nucleated villages, in and of themselves, I don't think are the sign of increasing population. Population did increase. I think the nucleated villages are really a sign of gathering rural populations into a type of village that makes it much easier to extract surplus from them, to put it bluntly. It represents a sort of much more systematic method of surplus extraction, of taxation and so on. I don't think it represents in and of itself, or was the result of there being so many people that they kind of had to sort of group together in that way. I think it was a deliberate strategy.
Thank you all for your questions, and please join me in thanking Professor Hamerow one more time.